Regression and regression analysis. So this is actually a two-area topic, whereby in the first place we are supposed to look at an area on correlation. We need to start by looking at an area on correlation, and then later we also discuss about the regression. Correlation, it is the measure of the level of interrelationship between two variables. It is the measure of interrelationship between two variables. So when we are trying to compute the correlation, we are trying to find out how two variables, we are going to be talking about two variables, how these two variables are going to be related. In simple terms, we have cases like, or two variables like price and sales volume, the quantity that is going to be sold. So we wanted to see if we adjust the price either downwards or upwards, what would be the change or what would be the effect on the quantity that will be sold. So here, for those two variables, one of the variables at A is what we call independent variable, which is normally denoted as X. And then we have another variable we call dependent variable, which we normally denote by Y. So in simple terms, we are trying to measure what will be the effect. The independent variable is what we call the driver. It is what is being adjusted. And then after the adjustment has been made, we find out what will be the effect on the other one, how the other one will be affected by that change. For example, you increase the price of your product by 5 shillings. What will be the effect of that adjustment on the quantity that will be demanded? So the other variable now that is being affected, it is what we call the dependent variable. The dependent variable. So this variable, in this case, it is the quantity that is sold, depends on the price. Depends on the price. The quantity that you are going to sell depends on the price. Another case is a case whereby we are talking about maybe the advertising budget or the marketing budget versus the sales volume. The sales volume. What will be the effect of increasing or reducing the marketing budget on the quantity that we are going to sell? So when we are trying to measure the relationship between the budget, the advertising cost, versus the sales volume or the sales revenue, there again we are trying to measure the correlation between those two variables. You can be a farmer as well. You are going to look at maybe the quantity of input, maybe it is fertilizer, versus the quantity of harvest, which is the produce. So when you are trying to measure that kind of correlation, how these two variables are relating with each other, then you are determining the correlation. So correlation, it is the measure of interdependence or interrelationship between two variables. One of those variables, the one that we are adjusting, is the one we call independent. The one that will be affected by the adjustment of the independent variable is the dependent variable. And for our computations, the independent variable will be denoted by X, the dependent variable will be denoted by Y. As far as correlation is concerned, we are going to calculate two types of correlation, or before I go there, we have got two types of correlation. Correlation can either be positive or it can be negative. Correlation can either be positive or it can be negative. That is from the general outlook. A positive correlation exists where increase in this independent variable will result into increase in the dependent variable. A good example is about advertising budget versus the sales that is going to be realized. So you realize that if you increase the advertisement, you expect also the sales to increase. So the relationship between advertisement and sales will be a positive kind of correlation. We are going to have a positive correlation because in the dependent. Also, decrease in the independent results into decrease in the dependent. When we are going to have such kind of a case, you increase this, the other one also increases. You reduce this, the other one also reduces. That is a positive correlation. A negative correlation exists where increase in the independent results into decrease in the dependent, or decrease in the independent results into increase in the dependent. So they are not moving in the same direction. And a good example there is the price that you charge versus the quantity that you sell. You expect that when the price is increased, the quantity that will be sold will reduce. When the price is going to be reduced, the quantity that will be sold will increase. So the price and the quantity here are said to be negatively correlated. They will be said to be negatively correlated. That is another aspect that we need to understand, that correlation can either be positive or negative. Positive correlation exists where increase in dependent results in the increase in the dependent variable. And then decrease in the independent results into decrease in the dependent variable. And I've given you an example. It is advertisement versus sales. You increase advertisement, sales increases. You reduce advertisement, sales reduces. That is a positive correlation. Negative, you increase price, the quantity goes down. You reduce the price, quantity goes up. Those two variables are negatively correlated. Then you also need to understand that the level of correlation, or the correlation coefficient for that case, the correlation coefficient. The correlation coefficient, or the value of correlation, it can have a maximum of +1 and a minimum of -1. In between that, we have 0. So the highest correlation that can exist, it is +1. The lowest correlation that you can have is -1. Then this one means it is a perfect positive correlation. A perfect positive correlation. Perfect positive correlation exists where you, for example, if you are talking about advertisement and the sales, you double advertisement, sales also doubles. You reduce advertisement by a half, sales reduces also by a half. When they exist like that, that is a perfect positive correlation. Perfect negative correlation, on the other side, occurs whereby if you reduce the price by maybe 10 or you reduce the price by a third, the quantity will increase by that a third. So if you reduce the price by a half, then the quantity that will be sold will increase by double. So when they are moving in the same direction by the same magnitude, it is a +1, also a -1 kind of correlation. When it is 0, means no correlation. 0 means no correlation. This one means perfect negative correlation. Perfect negative correlation. In between have that, we have +0.5. In between this, we have -0.5. So this region, we normally say it is a high positive correlation. It is not perfect, but it has a high positive correlation. This region here, it is a region of low positive correlation. That region, it is low negative correlation. If it has not reached -0.5. If it is -0.5 and above, it is a high negative correlation. So in most cases, when you are told to compute correlation, you will be told to calculate the correlation. Then part 2, it will ask you to interpret your answer. It will ask you to interpret your answer. Let me get just a minute. from there now, we can go to the computation part. How do you measure correlation? How can you be able to calculate correlation so that you can get your answers between +1 and -1? So we have got two types of correlation that you can be able to compute. One, it is what we call the Spearman's. Sometimes it is known as the Carpiason. Correlation coefficient. The Spearman's, sorry, it is known as the Spearman's. That is the first one. The Spearman's or Carpiason correlation coefficient. This one is normally calculated by the formula. The formula is a bit lengthy, but it is easy to understand. It is normally denoted by small r, whereby r is equals to n summation of xy minus summation of x times summation of y divided by a square root. Divided by a square root of n summation of x squared minus summation of x into bracket squared. You multiply by the square root of n summation of y squared minus summation of y into bracket squared. Remember, I started by telling you that x is normally an independent variable. Independent variable. Y, it is the dependent variable. So it is actually those figures here. So if you are told that, we have, for example, here, the month, and here we are given the number. What can I say? We are talking about advertisement cost. Advertisement cost, and here we have the sales. This one is in 1,000. If the sales is also in 1,000, even something like this. This is maybe January, February, March, April, and May. You are given that, then you are given the data. In the month of January, the advertisement cost was maybe 5,000. We sold goods worth 15,000, or the sales revenue was 15,000. When it was February, we used 8,000. Remember, these figures are in 1,000. We made sales of 16,000. When we went to March, we increased our advertisement cost to 12,000. Then we realized 21. Then in April, the advertisement was 9, and then we realized maybe 17. And then in May, the advertisement cost was 10. We realized maybe, let's say, 15. And then now you are told calculate the Carpiason correlation coefficient. Calculate the Carpiason correlation coefficient. So the moment you are able to understand this formula, n summation of xy minus summation of x times summation of y divided by the square root of nx squared minus summation of x squared times n summation of y squared minus summation of y squared, you need to come and now prepare the relevant document. Remember, the advertisement cost will be the driver. It is x. The sales is the dependent, the y. So you will come here and insert the necessary columns. Actually, we need only the addition. Here we need the sum of xy, so we need xy so that we can add them. Here we need the sum of x, we just add this x. The sum of y, we add the y's. Then we also need the sum of x squared, so we need x squared so that we can sum it. And we also have, or we need the y squared so that we can add it. So we do it. We do it. So when we say xy, it simply means we multiply the x value times the y value. Here we shall have 5 times 15, which gives you 75. 8 times 16, which gives you 128. 12 times 21, which gives you 252. 9 times 17, which gives you 153. And 10 times 15 is going to be 1. For the x squared, you square the x values. 5 squared is 25. 8 squared is 64. 12 squared is 144. 9 squared is 81. 10 squared is 100. Y squared, you simply square the y values. You simply square the y values, which is 225. Then we square the 16, you find it is 256. You also square 21, you get it is 441. And then we have 17 squared, which gives you 289. And then 15 squared is 225. Then you can add all these. Add all that. So if you add this, 225, 225 plus 289 plus 441 plus 256 plus 225, you get 14. Then we have 25 plus 64 plus 144 plus 81 plus 100, you get 414. Then we add the xy, we get 75 plus 128 plus 252 plus 153 plus 150. You get 7. We also add the y's, which is 15 plus 16 plus 21 plus 17 plus 15. You get 84. The x, 5 plus 8 plus 12 plus 9 plus 10, you get 44. Once you have those summations, these are now what we call the summations. The summation or the sum of x, the sum of y, the sum of xy, the sum of x squared, and the sum of y squared. With those values now, you can replace them in the formula and be able to get the Spearman's correlation coefficient, where n is the number of observations. Here we are talking about how many months? 1, 2, 3, 4, 5. So our n is 5. The number of pairs of x and y, they are 5. So we are going to come here and say, don't know how I'm going to put it so that you can be able to see. Let me compute this here. N is 5, so our r, small r, will be equal to 5, that is n. It's 5 times summation of xy. And the summation of xy is what? 78. Minus summation of x times summation of y, which is going to be what? 44 times 84. Then you divide by, you take a very big square root, and which is 5 times the summation of x squared, which is 414. You minus the summation of x into bracket squared. The summation of x into bracket squared is not the same as the summation of x squared. The summation of x squared is simply take the sum of x, which is 44, and then you square it. 44 squared. You have that part. Then you multiply by n, which is what? Which is 5 times the summation of y squared. The summation of y squared is 1436. minus the summation of y squared. You take the sum of y, which is 84, then you square. You work out that, you get your solution. You get your solution. So let me do the numerator part. 5 times 758, you get that 790 minus 44 times 84, you get 36, 96. You divide by the square root. 5 times 4, 14. You get 2070 minus 44 squared, 1936. That one you multiply with 5 times 14, that's 6. You get 7180 minus 7056. So if I can do the numerator part, that is 790 minus 3696, you get 94. All over the square root of 2070 minus 1936, you get 134 times 7180 minus 7056, you get 134. So this is the same as 94 divided by the square root of what? 134 times 124. You get 16616, which is going to be 94 divided by the square root of 16616 is 128.9. So if you do 94 divided by 128.9, you get 0.73. 3 is 2 decimal places, and that is your answer. This is your Spearman's or Carr-Pearson correlation coefficient. That is the Spearman or Carr-Pearson correlation coefficient, 0.73. So that one you can be able to tell the level of correlation between the advertisement and sales. Remember we said, or we have this chart. Let me just take you here, then I'm going to bring you there. We have the chart that can be able to assist us to interpret the level of correlation. We said if your correlation is between 0.5 and +1, it is a high positive correlation. In this case, our answer is 0.73. 0.73 is within this range. So in simple terms, there is a high positive correlation between advertisement cost versus the sales revenue that will be realized. That is what it means. That is what it means. That is what it means. And a high positive correlation means that the moment the cost increases, the other one also increases with a big margin. So high positive correlation. So I hope you are digesting that. So it's a matter of understanding how this formula is applied. Understanding how the formula is applied. You need to get to the column for XY. This one will not be given in the question. This 3 will be given only the X and Y. From the X and Y, you create the XY, X squared and Y squared. Then you substitute the totals in this formula. Then you compute that. So having said so, I want us to take you to the next type of correlation that you can be told to compute. The second type of correlation, number 2, it is known as the Spearman's or Carl-Pearson rank correlation coefficient. That is the second type of correlation that we can be told to determine. The only difference is that, remember, this one has got the word rank, the other one does not have rank. This is the type of correlation that is measured on the values that are ranked. When you rank some values in a way, you can be able to determine the correlation between the ranking. For example, if maybe I and you, we are judges, or I can put it in simpler terms, we are maybe interviewers. We are interviewing some candidates. And then as we interview them, we award them marks. Maybe we had 5 candidates for a particular job. So as we ask them the questions, we record the scores independently without consulting each other. Then from the scores, we can be able to rank the first candidate to the last candidate. So we can be able to measure my ranking with your ranking, whether we are correlating. The candidate who is preferred as my number 1, is that candidate your number 1 as well? The candidate that appears last, is it the same candidate that is appearing last in your case? So when we are having the same level of reasoning and scores, then we can say that there is a positive correlation between our ranking. But when you find that where I gave the candidate highest scores, in your case you gave the same candidate the least score, then we are negatively correlated in terms of awarding the scores. So for this one to be applicable, it is where we have got ranking. We rank them from position 1 to position last. And in that case, this one is normally abbreviated by capital R. And the rank correlation coefficient is given by 1 minus 6 summation of this squared divided by, remember this divide is up to where we have 6. It does not come over to where we have 1. It is up to here. 6 summation of this squared over n into n squared minus 1. So, if, for example, we were talking about the ranking about candidates, if we have candidate A, B, C, D, and E, then ranking, rank by A, and then we have the rank by maybe D, that is the manager. If we want to measure the rank correlation coefficient, we must be given the first and the up to the last. Maybe this candidate was number 3, this was number 2, this maybe was number 1, number 5, and number 4. Then according to that B, this was number 2, this was number 1, this was maybe number 3, number 5, this is number 4. And then this is number 5, according to Judge B. According to Judge A, number 1 was candidate C. According to B, it was candidate B was number 1. And then we are told, can you compute the rank correlation coefficient? This one is a bit easy. When you are given the ranking, what you do, you get this. You get B, which will assist you to get this one. Hello? Somebody with a question? Okay. You get D, and then D squared. D is the difference between the ranking. You just take ranking 1 minus ranking for Judge B. 3 minus 1 is 1. 1 squared is 1. 2 minus 1, you get it is 1. 1 squared is 1. 1 minus 3, it is negative 2. When you square negative 2, you get positive 4. 5 minus 1 is 1. 1 squared is 1. 4 minus 5, it is -1. When you square -1, you get +1. So all our d squared must be positive. Then what we do, remember here we are talking about the sum of d squared. So we simply add the d squared. This is 2, 6, 7, 8. So our d squared is 8. Once you have that, you can comfortably be able to calculate the rank correlation coefficient. Your R will be equal to 6 minus 6 times summation of d squared. So it is going to be 6 times summation of d squared, which is 8. The sum of d squared is 8. Then we divide, not, sorry, this is 1. This is 1. This is 1 minus that. And then here, 6 times summation of d squared, we divide by n. N is the number of pairs, or the number of candidates. In this case, there were 5 candidates, A to E. So it is going to be 5 into 5 squared minus 1, which is 1 minus, that is 48, all over 5. Remember, 5 squared is 25 minus 1, which is 1 minus 48, all over 5 times 25 minus 1 is 24, which is equal to 1 minus what? 48 divided by 5 times 24, you get 120, which is equal to 1 minus what? 48 divided by 120, 0.4. 1 minus 0.4, you get the answer 0.6. That is your rank correlation coefficient. Rank correlation coefficient, it is 0.6. When it is above 0.5 and it is positive, we say that there is a high positive correlation between ranking by A and ranking by B. A high positive correlation when it is above 0.5. That is how you do the rank. So you simply must have the first one to the last one for each case. Then you take the difference between the ranking. It gives you the difference, the deviation. This is the deviation. And then you square the deviation. If it was negative, if you square a negative, it becomes a positive. So all of your d squared should be positive. And then you add them, you get the sum of d squared. So our 8 is the sum of d squared. We have added all the d squared to get this. So it is 6 times the summation of d squared. So it is going to be 6 times 8. N is the number of pairs, or the number of candidates that were there if it was about candidates. Any question? Okay. In some cases, still under the rank correlation coefficient, the values might not have been ranked. So you can be given the scores instead of the ranking. So you can be given the scores. You can be told that we had 6 candidates in a beauty contest, whereby we had these are the participants. Maybe it is A, B, C, D, E, and F. We had 6 participants. Those 6 participants, as they were presenting their skills, we found Judge A. We gave the scores, Judge A scores, Judge B scores. So gave maybe candidate C 90. This one was given 64. Maybe this one was given 58. This one is 68, 71, and maybe 52. That is the scores. Judge A gave A 58. B was given a score of 64, like that, like that. For Judge B, this one was given maybe 85. This one was given maybe 46, maybe 75, 80, 63, and maybe 59. Just random. And you are told to calculate the rank correlation coefficient. You cannot get this difference to be your D. These values have not been ranked. These values have not been ranked. We don't know who was number one up to number last. So you have got a responsibility of ranking them. For this case, you will first of all rank them. According to Judge A, we call it rank 1 or rank A. According to Judge A, who was number one up to number last. So number one is the one with the highest score, followed by, this is number 2, followed by number 3 is there, followed by number 3 is great. Then this is number 4, number 5, and then number 6. According to that Judge A. According to the scores, you can be able to rank them from the first to the last. According to Judge B, number 1 was here, followed by, this is 8, followed by, sorry, number 1 is here, followed by this one, number 2, then this one is number 3, that is number 4, this one will be number 5, and then we have number 6 here. That is rank B. Then from the ranking now, that is where you can get your D and D squared. You get the difference of the ranking, not the difference of the scores. So it is 5 minus 4, 1. This is negative 1, 0, 1, 0. If you square this, you get 1. Negative 1 squared is 1, negative 1 is 1, 0 squared is 0, 1, 0. If you add your D squared, you get what? This is 4. You get the summation of D to be equal to 4. If therefore you are told to calculate the rank correlation coefficient, your R will be equal to 1 minus 6 times 4, 6 times the sum of D squared. Then you divide by n. In this case, there are 6 participants, so it is 6 into 6 squared minus 1, which is equal to 1 minus 24 over, this is 36 minus 1, 36 minus 1 is 35, 6 squared is 36, 36 minus 1 is 35, so what is 35 times this 6? You get it is 2 times. So it is 24 divided by answer, you get 1 minus 0.11. You get the answer is 0.889. That is the R, which is going to be what? A very high positive correlation. Very high positive correlation. So that is how we do it. That is how we do it. And that is all about correlation. You can get the Spearman's or Carl-Pearson correlation coefficient. You can get the rank correlation coefficient. And I've seen or I've given you the different options that you can have. With that, now we can go to the next area, which is the regression analysis. Regression analysis. Regression analysis. It is also known as the risk cost. So for the regression analysis, it is predicting estimating model. It is a predicting or estimating model. It is used to determine the predicting or estimating or estimation, used to determine the estimation equation in the form of y is equal to a plus bx. It is used to determine the estimation equation in the form of y is equal to a plus bx. This is the estimation equation, where a is, let me start with y. Y, it is the dependent variable. X is the independent variable. A, it is the fixed component. B, it is the variable component. B is the variable component. For you to be able to determine the estimation equation, you need to determine these two. You compute these two values. You compute those two values, and once you have computed the value of B and the value of A, you come and substitute them there. You substitute them in this equation y is equal to a plus bx. So A, you will have computed, you know it. B, you know it. You substitute it there. So for example, if A was maybe 20 and B was maybe 6, your equation will be y is equal to A, which is 20 plus 6x. You just replace A and B in that particular expression to get your regression equation. Let me give you an example. Let me give you an example here. We can be given data about advertisement cost versus the sales that are realized for a particular number of periods. And then now we are told, using that data, we predict what will happen in the future. So, like for example here, we have advertisement. Maybe it is this is normally our X, the independent, the one that it is driving the other one. We adjust advertisement, cost becomes affected. So that is the independent, that is the X. Maybe it is in 1,000, maybe it is 6, 4, 9, 8, 7, and maybe let me say 3. Then we have got sales. If we adjust advertisement, we affect sales. So it is now going to be our Y, which is known as the dependent, the one that is depending on this. It is also in 1,000 for simplification. So it is maybe 10, maybe 8, 13. Let me say 10, 9, and maybe 5. Just for illustration. And now you are told A, determine the regression or the estimation equation using the risk square. This is the risk square, not the risk cost. The risk square. The risk square, not the risk cost. Sorry for that. The risk square method. So for you to be able to get the value of B, we normally start with B. B is computed by n summation of xy minus summation of x times summation of y divided by, this one there is no square root now, n summation of x squared minus summation of x into bracket squared. Just that. That is how we get to B. The value of A is given by summation of y minus B summation of x, then we just divide by n. That is how we get to the value of A. So, but always start by computing B, because the answer for B is used here to determine the answer for A. So what you do, come here and compute xy and only x squared. Only those two. In this case, we don't need the y squared. So you do xy xy, 6 times 10 is 60. 4 times 8 is 32. 9 times 13. 117. This is 80. You get 63, 15. X squared, you square the x values. This is going to be 36, 16, 81, 64, 49, and then 9. Then we shall add all of them. We add the x's, we get the sum of x. 6 plus 4 plus 9 plus 8 plus 7 plus 3. That is 37. 10 plus 8 plus 13 plus 10 plus 9 plus 5. You get 55. The other one is 60 plus 32 plus 117 plus 80 plus 63 plus 15. You get 367. The other one is 36 plus 16 plus 81 plus 64 plus 49 plus 9. You get 255. Once you have those values, you can comfortably compute your A and B. You can comfortably compute your A and B, but always start with B. Your B is equal to N. We had 1, 2, 3, 4, 5, 6. We had 6 pairs. So our N is 6 times summation of xy, which is 367, minus summation of x times summation of y. Summation of x is 37 times summation of y, which is 55, divided by n summation of x squared, which is 6 times summation of x squared. X squared, the sum is 255. Then you minus summation of x into bracket squared. That is 7 into bracket squared. This is 2202 minus 20, 35 over 6 times 2, 55, 15 bracket minus 1369. From there, 2202 minus 2035, you get 167. Divided by 15 brackets minus 1369, you get 161. So your B will be equal to what? 167 divided by 161, you get it is 1.04. Once you have your B, you can get now your A. Your A will be summation of y is 55, minus B, which is 1.04, is answer here, times summation of x. Summation of x is what? Summation of x is 37. Then you divide it by n. Our n is 6. Equal to 55 minus 1.04 times 37. You get that 8.48. You divide by 6. This is 16.52 over 6. Our A is what? 2.75. 2.75. Once you have your values of A and B, you can comfortably get now the equation. The equation in form of y is equal to A plus bx. A plus bx. y is equal to A, 2.75 plus 1.04. That is your, and then you include accident. That is your cost estimation equation, which you can use to estimate anything. So in the question you can be told now, estimate the sales that will be made when the company sells, for example, 13,000 units. This was in thousands. So if the company sells 13,000 units, what will be the sales? We are now using this equation to estimate that. So you can come here and say that if, remember the units here, sorry, I think I've given you the wrong explanation here. Here it is talking about advertisement. So the question can be, estimate the sales that the company will realize if the advertisement, not the units, if the advertisement is 13,000. If we advertise with 13,000, what is the expected sales revenue from that? So you need to come here and say this. If advertisement, remember advertisement is your X, is 13. In simple terms, when X is 13, what will be Y? Y is your cost. If we advertise with 13,000, then it simply means that 13,000 is X because all the advertisements will be presented by X. What will be Y? Y is the sales. So in simple terms, you should come here and say when X is equal to 13, the figures are in thousand. We shall convert it into thousand later on. When X is 13, 13 is the advertisement cost. Y will be equal to 2.75. We are using this equation plus 1.04 times X, but now our X is 13. We multiply by 13. So it is going to be what? 2.75 plus 1.04 times 13. You get what? 13.52 plus 2.75, you get 16.27. But because the values are in thousand, it is going to be 16.27 times 1,000. If you convert them into thousand, you get 16,270. This is the sales revenue that you can be able to realize when we sell 13 or we advertise with 13,000. So you just look at what you are given. If you are told that the advertisement is 13,000, this is the cost estimation equation. So you need to come here and instead of having X, you replace with the value that you are given, because advertising is represented by X. Is represented by X. You get your cost estimation equation, then you will be replacing the X with the advertising cost that you want to use to predict the sales. If maybe you are told if the advertising cost is 15,000, you replace X with 15. If you are told the advertisement cost of 2,000, you replace X and you put 2,000. Then you are able to get your Y. Your Y is the sales. Your Y is the sales. That is how we do the regression. So regression is simply a predicting model. We get the data. We use the data first of all to get the estimation equation, the predicting, the forecasting equation. Then using that equation, we can be able to be replacing one of the variables with what we are given to be able to determine the other variable that we are forecasting. Good. Good. And by so doing, that brings us to the end of the topic on correlation and regression. And then we need to cover something small on the break-even point before we conclude our classes. Let me end this recording. Don't know how I'm going to do it. Mhm. Don't want to lose this recording, but at the same time,